Okay, here are quiz 3 solutions for Math 112. First problem has to do with the log rules, so I wrote out the log rules so you can reference them here. We're supposed to simplify this mess here. Apparently the answer will just be a single number. So okay, let's get started. Let's see. The first thing you'll want to do is apply the third log rule. You might think you can apply the first log rule up here in the numerator, but you can't because of these coefficients here. However, you can get rid of these coefficients using this third log rule kind of in reverse. What you have is something that looks like this. You can make it look like this. So I can say that what I have is the log of 8 raised up to the 1/3 power plus the log of the cubed root of 50 raised up to the 3rd power. Fine. And I'm going to divide that whole thing by 1 plus the log of the negative of the natural log of 1 over e. So the natural log of 1 over e, maybe I'll just rewrite that as the natural log of e to the negative 1 power. Because that's one way you could write that, because 1 divided by e is the same as e to the negative 1 power. But 8 to the 1/3 is just the cubed root of 8. So really all I have in the numerator here is the log of 2 plus the cubed root of 50 cubed is just 50. So I got the log of 50. And then down in the denominator, I got 1 plus the log of the negative of the natural log of e to the negative 1 power is asking you to what power must you raise e to make it e to the negative 1 power? The answer to that is negative 1. So really, this whole thing turns into a negative 1. So what I have is the log of the negative of negative 1. In other words, I got the log of 1 down here. So up in the numerator, I can now apply my first log rule and rewrite that as the log of whatever 2 times 50 is, happens to be 100. And the denominator, I got 1 plus the log of 1. Log of 100 is just 2. Log of 1 is 0. So my answer is just 2 over 1, or 2. And the reason the log of 100 is 2 is because there's an implied 10 here as the base. So it's asking you to what power must you raise 10 to make it 100? The answer is 2. To what power must you raise 10 to make it 1? The answer is 0. So 2 is the answer. Moving on, this mess. Express this huge jumble in this form. And it should work out that A, B, C, and D are all either plus or minus 1, 2, or 3. See if we can get that to happen. What I would do first is looking at this term. You can rewrite that using your second log rule as the log of the square root of 8x cubed y to the 4th power minus the log of 2000 z to the 3rd power. Because I have the log of a quotient, I can rewrite that as the difference in two logs. And then I still got this minus the log of the square root of 2x. So I can apply my third log rule to take this square root, which is the same as raising it to the 1/2 power, and rewrite this as 1/2 times the log of, all right, I'll wait another step before I do any more, 8x cubed y to the 4th minus the log of, I'll just leave this alone for now, minus 1/2 times the log of 2x. Now I can apply the first log rule a bunch of times because I have a bunch of stuff multiplied together here. 8 times x to the 3rd times y to the 4th, 2000 times z to the 3rd, 2 times x. I can apply a whole bunch of first log rules to rewrite this as 1/2 log of 8 plus the log of x cubed, which is the same as 3 log of x, plus the log of y to the 4th, which is the same as 4 log of y, minus the log of 2000 plus 3 log of z. So this is 2000 times z cubed, so I can make that the log of 2000 plus the log of z cubed. But the log of z cubed is 3 log of z using your third log rule. And note I need the parentheses because I'm subtracting this entire thing, so I want to subtract this entire thing. Then finally I got minus 1/2 the log of 2 plus the log of x. This huge mess here. I can simplify it by distributing. At this stage, do you want to do this or not? I'll wait. Okay, so I'll distribute through. I'll get 1/2 log of 8 plus 3/2 log of x plus 2 log of y minus the log of 2000 minus 3 log of z minus 1/2 log of 2 minus 1/2 log of x. Now if you start combining like terms, I got 3/2 log x minus 1/2 log x. I have a total of 1 log x. For my log y's, I just have this term here, which is plus 2 log y. Log z, it looks like I got -3 of these log z's. Then I got a whole bunch of numbers. I have plus 1/2 log of 8. And I have minus 2000 minus the log of 2000. And then I have this minus 1/2 log of 2. So the x, the y, the z, those are all taken care of, and sure enough the coefficients are 1, 2, and -3, which are all on my list. Just have to figure out what this mess is equal to. Maybe I'll do that off to the side. All this stuff I can figure out. It's a little messy. I can figure out up here on this side. And the way I can do that is I can say it's the log of 8 to the 1/2 minus the log, how about plus the log of 2000 to the -1 power plus the log of 2 to the -1/2 power. And so I can put those all together and say that I got the log of 8 to the 1/2, 2000 to the -1, 2 to the -1/2. So I have the log of 8 to the 1/2 divided by 2000 times 2 to the 1/2. So I have the log of 8 to the 1/2 divided by 2 to the 1/2 is just 4 to the 1/2 over 2000. But 4 to the 1/2 is just 2. And 2 over 2000 is the same as 1 over 1000. And the log of 1 over 1000 is -3. So what I get for my final answer is the log of x plus 2 log of y minus 3 log of z minus 3. And maybe to help with the arrows, this minus 3 right here goes in here. Maybe I'll throw a box around that, throw some equal signs in here, and call that one good. Pretty challenging problem, although you saw something pretty similar on the worksheet. Okay, solve the following equations for x. So now I have equations, not just expressions. So I'm not trying to simplify, I'm trying to solve for x. I want to isolate the x. There's only one x in this expression, so I can get it all by itself. First, add 5 to both sides. 2 log base 2 of 4 to the 3x minus 2 power minus 8 is equal to 6. Divide by 2. Log base 2 of 4 to the 3x minus 2 power minus 8 is equal to 3. Do 2 to both sides of the equation. 4 to the 3x minus 2 minus 8 is equal to 2 to the third power. 2 to the third power is just 8, so I have 4 to the 3x minus 2 minus 8 is equal to 8. So 4 to the 3x minus 2 is equal to 16. So if I take the log base 4 of both sides of the equation, I got 3x minus 2 is equal to the log base 4 of 16. So 3x minus 2 is equal to 2, because the log base 4 of 16 is asking you what power do you got to raise 4 to make it a 16. And to solve this equation, you add 2 to both sides and then divide by 3. All right, and then this mess of a problem. We got two x's here, which makes it a little bit more challenging. They're both up in the exponent, so to get them out of the exponent, we've got to take a log. Which log? It doesn't matter. You take the log base 5, log base 50, natural log, regular log, whatever the hell you want. I'm going to take the natural log and say that I got the natural log of 5 to the 2x power is equal to the natural log of 50 to the x minus 1 power. And now the reason I took the natural log is so I could apply my third log rule and call this 2x natural log of 5 is equal to x minus 1 times the natural log of 50. Now I don't have my x's up in the exponent, although it's still challenging because I have multiple x's. And the way I'll solve that is I'll get all of the terms with x's in them on one side of the equation. So I'll take this natural log of 50 and I'll distribute it through these parentheses so that I can move the pieces around more easily. So to get all the terms with an x in them on one side of the equation, this term and this term, maybe I'll take this negative natural log of 50 and add it over to this side. So I have the natural log of 50 over here. And then on this side I got x natural log of 50, and then I'll subtract this term, so minus 2x natural log of 5. And the reason I did that is now I can factor out an x from each of these terms. So I got x times the natural log of 50 minus 2 natural log of 5 is equal to the natural log of 50. So to solve for x, divide by all that junk, and you get that the natural log, x is equal to the natural log of 50 divided by the natural log of 50 minus 2 times the natural log of 5. Which is a perfectly fine answer. You'll get full credit for this. However, you'll get a bonus point. In fact, I think you should get 2 bonus points. I'm going to change that if you can go further. And the way you could go further is you could say that in the denominator I can apply my second log rule. Actually, no, that's not true. You can apply your third log rule first to rewrite this negative 2 natural log of 5 as negative natural log of 5 squared. And the reason that helps is 5 squared is just 25. So you can now apply your second log rule, which says if you have the log of something minus the log of something else, you can rewrite that as the log of this divided by this. So 50 over 25. So really this thing here is just the natural log of 50 divided by the natural log of 2, which you can rewrite using your change of base formula as the log base 2 of 50. Extra credit. So there you go. That's the end of this video.